I'm Kanchan the Tech Pro, and today I'm going to explain Quicksort algorithm for you line by line, but my focus will actually be how to write the code and understand it. So how to actually do Quicksort, the concept of how Quicksort works, you can read it and understand it. But to write the code is what I'm focusing on. So there are two things about Quicksort. One, partitioning. I'm going to explain it in a minute. And two, recursion. So Quicksort works by actually continuously performing partitioning on a particular array or on a particular data, and then continually performing recursion on the subsets. So let's take, for example, let me just take a typical example and then we continue from there. So let's say we have something like this. So now we have, let's say 1, 2, 3, 4, 5, 6. So let's say we have 2, 7, 9, 1, 3, 6, 4. So for Quicksort to sort this data you have here, the first thing it does is choose a pivot, right? So the first thing is choose a pivot. Now to choose this pivot could actually be you take the midpoint or randomly choose a pivot. So but normally in writing the program we take the midpoint. And then the next thing is check on both sides of the pivot for elements that are greater or lesser than the pivot. So what we are saying is that after choosing a pivot, choose left and right index. So in this case, the left index is the beginning element to the left of the pivot. So this is going to be left. And the right is going to be the last element to the right of the pivot. Okay. So what we are now going to do is there's another thing called continuous swapping. Continuous swapping. So the next thing we are going to do is from the left index and the right index, provided they have not met each other, we are going to check the element here at this point and the element here. So in case we are sorting in ascending order, meaning that the very lower element will be at the left side and higher element will be at the right side. So we are going to compare the left and the right. So we are not actually comparing this element with the pivots, but we are comparing the left and the right element. Okay. So if we compare 2 and 4, we find out that they are in place. So 2 is actually less than 4. So we don't really do anything. So we move this to the next one, to 7, which is here. So in this case, left have moved 1 step to right. So at this point we have left. So we compare 7 and 4, and at this point we are going to swap 7 and 4. We are going to swap 7 and 4. And if we do that, I'm going to just draw the next iteration. So we are going to have something like this. We have 2 and we have 4. So at the end we have 7, we have 6, 3, 1, 9, right? So this is what we are going to have in the next iteration after the first partitioning and the first swap. All right. So remember that after doing this, at the end of the day, the left and the right index will meet at a point. And at that point, you simply partition again. So try to get this around your head, play around it a number of times. Or let's say at this second iteration, let's see what happens next. So what do we have here? So okay, let's forget it. So at this second iteration, now the pivot remains where it is at this point. While you are performing the continuous swapping, the pivot remains where it is. So recursion comes at the end of the day when the left and the right have met at a point. Okay, so this is where we did swap at this point. All right. So at this point, this and this, they are in place. So we are going to move this. If we move this, we find out that 6 and 4 is in place. So in that way, we can move this. So we find out that 6 and 9 is out of place. So we are going to actually swap 6 and 9. So if we continue on this way until we have all lower elements on one side and higher elements on the other side, we now partition and then perform quicksorts on one side and then recursively perform quicksorts on the other side. So let's see how this code will look like in Java, actually writing it in Java. So the first thing I'm going to do is to write a function called quicksort that handles, performs quicksorts, the initial quicksort on the overall list. And then I'm going to write another quicksort function that performs quicksorts on the partition. So this first function I'm going to write, the name is going to simply be quicksort, and I'm going to be explaining it to you line by line. Quicksort. So it takes an integer array. It takes an integer array. Of course, it could be anything. All right. So this is a function, public static. Let's say void, because it's an in-place sorting algorithm. That is what you want to know. So I'm going to just write it out so that you don't miss this point, because sometimes when we talk about efficiency, this is very important. So it's an in-place sorting algorithm. In-place sorting. So meaning that it doesn't return anything, and it doesn't take additional space. It actually sorts it while in place. So you have the same list is what you continue with. You are not creating additional lists. So that is what is called in-place sorting. In case you are talking, we're gonna be talking about algorithmic efficiency. All right. So we are going to simply perform quicksorts on this array. We are going to perform quicksort on this array, okay? And the starting point, the initial left is going to be from 0, and the initial right is going to be array.length -1. So -1 because it's a zero-based indexing, so it takes from 0 to array.length -1. So if we have 10 elements in this array, if we have 10 elements, then we actually will go from 0 to 9. So that's the zero-based indexes. So that's why we have array.length -1. All right, so it's complaining. The reason is because we've not actually written the actual quicksorts that is going to be called. So the key word here is recursion. So let's go ahead to write the quicksort now that is going to perform the actual quicksort algorithm. And this quicksort function is going to take the array, which could either be a subset, it's going to take the left and the right. So more like this particular quicksort we've called here. So let's write a public static void quicksort. So it's going to take an array, so int left, int right. Okay, so remember there is a line by line explanation. So the first thing we are going to do is to check if the left has met up with the right. If the left has met up with the right, then we don't have to do anything. So we are going to say if left is greater than or equal to right, we simply stop, because we simply return. Okay, So this is the first thing we do. So the next thing we are doing is to choose a pivot. So let me comment it. Choose a pivot. So one way to choose a pivot is to choose the midpoint. So I'm going to say int pivots is equal to array the element in the midpoint. So let's calculate the midpoint in the first place so that it becomes easier to understand. Midpoint is equal to left plus right divided by 2. Okay, so this is int mid, so it's going what is something. So we have int mid. All right, so this is what we have. So the next thing we want to do is to partition this list into a left and right subsets on both sides of the pivot. So we are going to take this array, take the left, extreme left and then extreme right, and also take the pivot. So to partition, we need left, we need right, and we need the pivot. So when it's there partitioning, it partitions from the beginning all the way to the pivot, and from the pivot all the way to the end. So let's do it. We are going to partition so the partition in so okay, we've calculated the midpoint, so we are going to now calculate the pivot. Pivot is equal to array of pivots. Okay. All right. So the next thing we want to do is to partition this list. Array of pivots. Array of mid. Yeah, mid. So how to partition is simply use a partition function. So we are going to say int index equal to partition array left and right. I'm going to explain it a little more after now. Pivot. All right. So now we've called a partition function to partition this array, and it returns the index of where the partition is. Now the partition point is actually not the pivot. The reason the partition point is not the pivot is because you might, let me just illustrate it by drawing just one more. So if we continue to partition, we could have, let me just draw it at this point. Okay, so we could have our pivot somewhere here, and as we are moving our left and right, we could find out that left comes up to this place, and once it's here, everything is sorted up. Okay, so if this is the case, it means that we now choose a partition where the list is actually giving us a situation whereby everything that is lower is on one side, and everything that is higher is on the other side. So the pivot just helps us to give us a guide when we are recursively performing the partitioning. So let's write it. If we after writing it, it will make more sense. All right, so we are now going to call quicksort on the two halves. Quicksort array. This time we have left, and we have index -1, and we are going to call quicksort again. Quicksort, and we are going to have array. We are going to have index. So we are going to have array. So we are going to have the index, that is the midpoint of the partition, and we are going to have right. All right. So this actually is how to implement quicksort algorithm. The question now is, how does partition work? What is this partition function? We are actually going to write a partition function. This partition function will be swapping continuously any two items that are out of place. I'm going to actually stop here because I have some time limit, and I'm going to continue in the next one. Immediately after this one, we are going to complete it by writing the partition function. So I'd like to remind you to subscribe to my channel if you've not done so.